sometime during their years together in Princeton. Einstein stopped on a walk, turned to his colleague, asked a strange question about the moon overhead. Did he really believe it wasn't there when nobody was looking at it? The moon was just Einstein's way of asking something much stranger. His colleague's name was Abraham Pace. He recorded this memory in a 1979 article in Reviews of Modern Physics, not a verbatim transcript, a trusted recollection written down decades later. But the deeper question behind it has never been fully settled. Here's what Einstein was really asking. In 1935, Einstein, with two colleagues, Boris Podolsky and Nathan Rosen, published a paper, now simply called EPR after their initials. The argument is careful, and it is worth following slowly. Take two particles that interact, then separate. Quantum mechanics predicts their properties stay linked, however far apart they travel. Imagine two coins, thrown from the same spot in opposite directions. Measure one, and quantum mechanics says you instantly know something about the other. The correlation appears instantly. It can't be used to send a signal faster than light. Nothing physically travels between them. Einstein and his colleagues then made a reasonable-sounding proposal. If you can predict the value of something with certainty, without disturbing it in any way, then there must be something real, out there, corresponding to that value. They called this a criterion of reality. Apply it to the two particles. You measure one. You now know something about the distant one, with certainty, without touching it. So that property must have been real, in the distant particle, all along, sitting there, waiting, whether anyone looked or not. But quantum mechanics does not include that property in its description. Which means, EPR concluded, quantum mechanics leaves something out. It is not wrong. It is incomplete. That was the whole thrust of Einstein's lifelong objection. Not that the theory failed, that it could not be the final story. Do properties already exist before we measure them, or does measuring play some part in making them definite? Einstein wanted the first answer, properties that exist, whether or not anyone checks. Niels Bohr disagreed. Fast. His reply came out the same year, same journal. A direct response, using the identical title. Bohr's point was subtle, and people still argue about exactly what he meant. Roughly, this. Einstein's criterion of reality contains a phrase doing enormous hidden work, without disturbing it in any way. Bohr argued that in quantum mechanics, you cannot cleanly separate the object from the whole experimental arrangement used to examine it. Choosing to measure one thing rules out measuring another. The setup is not a neutral window onto a property already sitting there. The setup is part of what defines which questions have answers at all. So the phrase, without disturbing it, quietly assumes the very thing under dispute. Neither man backed down, not once, for the rest of their lives. They argued at conferences, in letters, across decades. And for a long time, most physicists treated it as philosophy. Interesting, untestable, a matter of taste. For decades, nobody knew which view nature actually preferred. Then, in 1964, a physicist named John Bell found a way to test it. Bell asked what would happen if Einstein were right. Suppose the particles really do carry their properties with them, fixed in advance, the moment they separate. Little instruction sets, determined at the start. And suppose nothing travels faster than light between them. Physicists call these two assumptions together local realism. Local, meaning no faster than light influence. Realism, meaning the properties are already there. Bell showed something extraordinary. If both of those assumptions hold, then the results of certain measurements, repeated many times, at different angles, must obey a strict mathematical limit, The correlations can only be so strong, no stronger. Quantum mechanics predicts they can be stronger. Two different predictions, two different numbers, and a measurable difference between them. For the first time, the argument moved from philosophy into the laboratory. Nature would be asked to choose. In the early 1980s at Orsay in France, Alain Aspect ran the experiment. Pairs of entangled photons, detectors set at varying angles, thousands of runs. The results violated Bell's limit. They matched quantum mechanics, not the local, realist picture Einstein wanted. Those early results had known gaps, technical loopholes critics could point to. Maybe the detectors were missing too many photons, and the ones they caught were an unrepresentative sample. That's the detection loophole. Or maybe some signal, slower than light but faster than the experiment noticed, passed between the two detectors before the measurements finished. That's the locality loophole. So physicists kept closing them. By 2015, 3 separate teams in the Netherlands, Austria, and the United States closed the principal remaining loopholes, detection and locality, in versions built to remove them entirely. Same result, every time. In 2022, the Nobel Prize in Physics went to Alain Aspect, John Clauser, and Anton Zeilinger for exactly this body of work on entangled photons and Bell inequalities. Here's exactly what that does and doesn't mean. It means you cannot keep every one of Einstein's local realist assumptions and still match what the experiments actually show. Something in that picture had to give. Give up locality, and you can keep properties that exist in advance. Some interpretations do exactly that. Give up realism, and you can keep locality. You cannot comfortably keep both. It does not mean the moon disappears when you're not looking at it. No serious interpretation in physics holds that. Bohr's position, and the decoherence that explains why large objects behave classically, never implied it. Entangled photons, prepared carefully in a laboratory, measured at specific angles, are a very particular thing. Moon is not. That part was never actually in question. So Einstein's moon question, taken completely literally, already has an answer. Of course, it's there. But underneath the joke was a real question, still open today. Physicists still disagree about what the experiments are telling us. Copenhagen, many worlds, pilot wave theories, which give up locality and keep definite properties. Each one accepts the same experimental results. Each one pays a different price to explain them. None has won. Now, here's where this gets interesting. A little over 1100 years before Bell's inequality, a philosopher in India had already drawn a very different line between what's real and what's real enough. His name was Shankara, 8th century, give or take a few decades. He wasn't asking about particles. He was asking a different question. Is the everyday world the final truth, or one level of truth among several? Start with the example he actually uses, again and again. A man walks down a path at dusk. He sees a snake coiled in front of him. His heart races. He freezes. He steps back. His fear is completely real. His body responds exactly as it would to a real snake. Then someone brings a lamp. It's a coiled rope. Shankara calls this superimposition. The Sanskrit word is Adhyasa. Something is laid over something else and taken for it. The rope was always there. The snake never was. And notice how the error ends. Not by the man looking away, not by the rope changing. It ends when better knowledge arrives and cancels the earlier appearance completely. The tradition calls that cancellation sublation. The tradition, rooted in his teaching, describes 3 levels. At the lowest, private error. The snake that was a rope. The dream that felt solid until morning. Real to you, in the moment. Corrected. The instant better knowledge arrives. At the middle level, the ordinary waking world. Shared. Lawful. Consistent. This is where the moon lives here. Genuinely, functionally real. Not an illusion, not a private mistake. Everyone sees the same moon, and the tides move whether you believe in them or not. And at the highest level, what the tradition holds as the only truly unconditioned reality. Everything at the middle level, the argument goes, ultimately rests on this. Notice something important here. This is not a claim that the moon, or the everyday world, disappears when nobody's looking. Views where objects depend on being perceived do appear in some later interpretations, one specifically called Drishti Srishti Vada, but that is not the position argued in Shankara's own writings. In his picture, the middle level isn't cancelled by someone glancing away. It's cancelled, if at all, only by a completely different event, recognizing the higher truth beneath it. The lamp, not the closed eye. There's no evidence, to the best of current historical knowledge, that Einstein or Bohr ever encountered this specific doctrine. That link isn't being claimed here. So what's the actual parallel? Physics asks whether a property has a definite value independent of measurement. This tradition asks whether the world we measure things in is the final level of reality, or one level among several. Different questions, different tools, different centuries. But both refuse to let real enough to act on, and the final truth collapse into the same thing automatically. Einstein's instinct was that if you can predict it with certainty, it must be simply, fully real. Bohr's reply was that real needs a context before the word does any work. Shankara, in a completely different investigation, spent his life arguing that real comes in levels, and that mistaking one level for another is the fundamental error. Worth testing this directly, for a moment, not as belief, as something to actually notice. Right now, wherever you are, the room around you is completely reliable. Gravity holds, the chair supports you. Nothing about that is in doubt, moment to moment. But notice, last night, if you dreamed, a whole world appeared, felt just as solid while it lasted, then was simply cancelled the instant you woke. Not because you looked away from it, because a different, wider kind of knowing arrived. Inside the dream, you would have defended its reality. You had evidence. The floor held. The light worked. Something can be completely functional, completely real at its own level, and still not be the last word. Back to the walk near Princeton, one more time. Physics hasn't fully settled Einstein and Bohr's disagreement. The experiments ruled out one specific version of properties exist independently, always. What replaces it? Physicists still answer differently. The three levels teaching was never trying to answer that question. It was asking whether the world we all agree on is the final one. Two investigations. Neither one finished. Einstein asked if the moon needed watching to exist. Physics answered a narrower, stranger question instead. Over 1,000 years before either of them, a philosopher had already asked whether that question was even the deepest one available. Both left the same suspicion behind, that the word real is doing more work than we notice, and that we almost never stop to ask which kind we mean. Ancient wisdom, quantum mystery, direct knowing, this is quantum gnosis.